vegetation and vegetation averages.
Yeah.
Yeah, I can tell you, we have looked into this question because I read it and I felt like immediately something I had to test. And it's possible that you might have found a minor issue in how our vegetation is currently computed.
All right. Okay, good.
Good.
Yeah, it's a valid question at least.
It's good that there's progress and understanding in what we're saying. That's so we have this is still my experimental project, and I have the heat stress overlay. I'm going to switch it to displaying the vegetation.
Yeah.
And what we have is, I'm going to make the rest of the world concrete because I do not want everything to be vegetation. There we go. There. So we have a vegetation aspect in our heat calculation. And in the locations where there is no construction, it uses the vegetation fraction value. So we have open land here that has a vegetation fraction of 1. I can change that to 0.75 and recalculate. And then you see the light is turned slightly faded. The vegetation fraction is now 75%.
Yeah.
The same, in principle, should happen with constructions as well. So we have a nature building here, and depending on what kind of function you have, it already has a number of values filled in, and one of those values is the green space. And the accompanying attribute would be green M2. If I recall correctly, it's documented on our wiki. It's by default it's set to 1 for nature objects. I can change it to 0.5. But then indeed I noticed that the calculated vegetation fraction actually remains 1, which is strange, and also what you have pointed out in your post.
Yeah.
What makes it a bit more odd, which is why why it warrants a bit further investigation on our side, is that if I change it to something else which is ostensibly vegetation-ish, like a vegetable garden. Vegetable garden also has a green space attribute which can be modified, and this one does respond to changes from the green space value. I can change it to 0.25 or to 1, and it actually follows that number.
Yeah. Hey.
So it's the nature functions that seem to automatically set it to 1, which is odd, and which we're looking into further.
All right, then we'll leave that question open.
Yeah, all I can say for now is yes, you're right. Nature does work with either a 1 or a 0.
Yeah. Yeah. Okay. Yeah. And the nature, the average vegetation.
Yeah.
Is that something I can use for now?
Well, the average vegetation builds on what the vegetation actually outputs. So the heat overlay computes the physiological equivalent temperature in a number of steps. And one of those steps is determining the vegetation and how much effect that vegetation has on heat.
All right.
And the average, or the vegetation, is first computed per cell. So what is the fraction per cell? So here it's 75, here it's 0, here it's 25, etc. And the average is then the next step in the calculation with vegetation, namely for any given cell, for some definition, look at the extent around it, depending on wind speed, the extent changes, look at some extent around it and average out how much vegetation there is nearby. But it listens to the same data that you see in the vegetation overlay. So if it says 1 here, then it's going to compute with 1.
Yeah.
Additionally,
so if this one's not right, then the other one's also.
Additionally,
right.
The average vegetation fraction or the average vegetation output is also fixed to 2 very specific windows, which are quite large for most purposes, unless you're specifically trying to do something that averages it out over a large area. And it comes in 2 forms. It can come in a square or in a rectangle if it's very windy. So it would be very difficult to rodeo that into a workable value for other use cases.
Yeah. All right. Yeah, I'll have to wait with this one.
Yeah.
All right.
Is there, by the way, something to this use case about having the vegetation fraction, which maybe we could actually house in a different kind of solution? Oh
yeah. Well, the question is it's a pretty important question because, all right. The Hogeschool van Amsterdam is giving some help to ministries to how to make your city better resistant to heat. That's probably the best way to describe it. So they're saying, all right, let's have enough shade, like 50 or 40% shade for areas where you're walking, for instance, like important routes, routes like the market, or if you want to go to the train station, they should have 40% of shades. That's one of their points. And one of the others is that there should be a certain percentage of green in your in the area you are at. So to me, this is a very important question.
Okay.
Does that answer your question, or?
Yeah, because I think it gives some indication that perhaps your use case can be resolved in a different way than using vegetation output.
Great.
We have in Tygron a number of overlays, some very specific like the heat stress and water module, but we also have a few more generic ones, the intent of which is specifically that you can configure them yourself and as of recently even string them together to compute specific own results. So one of the things that you could do is you could create an average overlay, which would compute the green M2 in a specific location. Or rather, a specific location, just in general. You can set the averaging distance to 0, so you get basically exact markings of this cell has this exact average value. And we could say that is green M2.
And green M2 is already an existing attribute, or what?
Green M2 is the green space function value.
It's already something that exists, like.
Yeah.
All right.
If you have a function value, function, sure, default floors, whatever. Function values exist with a human readable name, like default floors for function values. But basically all function values also have an accompanying attribute, such as green, that's part of the environment. The green space function value has an accompanying attribute called green M2.
That's great. Yeah.
You don't really see it back in the interface because it's one of our predefined function values.
Yeah.
This also allows you to import buildings, for example, and if they have an attribute which is named green M2, then it automatically applies to that exact function value.
Yeah, great.
And that works for basically all the function values.
Yeah.
And so you can also create averaging overlays, which then average or highlight the green space. And the same can be done with the vegetation fraction. of, for example, of the terrains, vegetation fraction.
Mm-hmm.
And that also delivers, or that also provides some overlay. And the example I'm going to give now does not account for having buildings with a green space and a vegetation fraction in the same location. They would still, they would need to be checked in some way. But what you can do is you can create a combo overlay, which then combines the green M2 and the vegetation fraction into a single result, producing this as a map. So here the vegetation fraction is applied, that's 75%. Here the green M2 is applied, and that's 25%.
All right, let me see if I get it. The green M2 is something that's an attribute of buildings.
Yes.
Right? And the vegetation fraction is something that is part of the terrain type.
Correct.
Yeah, and if I combine those two, I get the percentage of green of a certain area, or in this case, the entire project.
Yeah. Working from the assumption that you want to emulate what happens in the vegetation overlay of the heat overlay, which looks at vegetation fraction and or green M2. This overlay now also looks at vegetation fraction and green M2, and thus delivers, in theory, the same result.
Yeah, great. Okay. Well, this is a great workaround.
There's you will need to check what happens if you have like a green building on something that also has a vegetation fraction. I'm not sure what happens in that situation. It'll probably add those two together. And that may warrant looking at using either one or the other, or some other form of check, maybe a mask. We have how-tos on our wiki as well.
Yeah.
But using the combination overlay, you can compute these spatial values yourself.
Yeah.
And you're also still free to use like an averaging factor to some extent in the overlays that serve as input for that. To maybe also smooth out those values and create like pathways and things like that.
Yeah. Yeah. All right. All right. So I have two options. Either I'm gonna use the workaround and check if it's working correctly, or modify it a little bit with masks or adding or subtracting certain areas, or I wait for you guys to check up on the vegetation average and the vegetation, or the vegetation. What was it called again?
The vegetation overlay or vegetation result type, or
that one.
Yeah. I would recommend using the combination overlay because that gives you a bit more power to actually control what exactly you're computing.
Mm-hmm.
You could also like debate on whether grass somewhere actually gives you shade or not, which is applicable or not to your calculation. And you could even then also factor in things like what is actually covering a pedestrian path or a road where people can then walk.
Yeah, no, I'm sorry. There were two examples. One of them is there should be shade, and the other one is what is the percentage of green, and it doesn't matter if there's shade or not.
Okay.
So, yeah, it doesn't matter if it's grass or trees. It's green, and they're using heat, or they're producing. They're making it cooler. Thank you.
I understand.
Yeah.
For both of those use cases, I would suggest that you experiment a bit with the combination overlay, because I think it's very easy to get it working for your use case, and I think it would be very powerful to then expand on to further increase the accuracy of what you're actually trying to calculate.
Yeah, I think so as well. Well, it gives me a better understanding anyway of how things are calculated in Tygron.
All right.